Good morning everyone. Today in this video we are going to learn about Thevenins theorem. Before going to learn about Thevenins theorem, I would like to discuss with you a technique known as source transformation technique. According to the source transformation technique, a voltage source with a series resistance can be replaced by a current source with a parallel resistance. This is known as source transformation technique. Now, based on that technique, we are going to learn about this theorem known as Thevenins theorem. If you see the statement of Thevenins theorem, it states that any two-terminal linear network consisting of voltage sources and resistances can be replaced with a single voltage source and a series resistance. Now, if you see the diagram, here you have a voltage source V and resistances R1, R2, R3 and a load resistance RL. According to the statement of Thevenins theorem, it states that this voltage source with these resistances, this can be simply replaced in this way. If you see a voltage source with a series resistance, this is known as Thevenins theorem. So a voltage source with the resistances R1, R2 and R3 can be simply replaced by a voltage source with a series resistance Rth. That is known as Thevenins theorem. So you may have any number of voltage sources, you may have any number of resistances. This can be simply converted into a single voltage source with a series resistance. That is the statement of Thevenins theorem. Now, to convert the voltage source with a number of voltage sources with a number of resistances into a single voltage source with a series resistance, we need to follow some steps. And this voltage Vth, we call it as Thevenins voltage, and this resistance Rth, we call it as Thevenins resistance or open circuited resistance. Now let us see how to calculate the Thevenins voltage, Thevenins resistance, and then how to calculate the current across the load resistance. Now, first step, let us think the given diagram to you is this. So they have one voltage source and resistances R1, R2, R3 and one load resistance. In order to convert the given circuit into its equivalent Thevenins circuit, first we need to find Thevenins voltage, then we need to find Thevenins resistance, then place the voltage source with a series Thevenins resistance and then load. Then you need to find the load across the current across the load resistance. Now first step is calculation of Rth. That is, we are going to calculate the Thevenins resistance. Thevenins resistance is also known as open circuited resistance. So what we do is, we simply remove this load resistance, that is, we open circuit it and then we find the equivalent resistance from the back side. That is, we have, if you see the step, we have removed the load resistance RL here, and from this side we need to calculate the equivalent resistance. So from this side, if I consider here, the current at this point is going to be divided, right? In here and here. So when current is divided, we say that these both are in parallel, and after these are parallel, their resultant will be in series with R3. Since current is being divided at this point, R1 and R2 are parallel and R3 is in series with the equivalent resistance of R1 and R2. That's the reason. And remember one point, whenever you are calculating Thevenins resistance, you need to go from back side. So from this side, you are open circuiting the load resistance, right? You are removing it and you need to calculate the equivalent resistance from this side. So R Thevenin is equal to this R3 plus, both are parallel, R1 R2 by R1 plus R2. In this way, we need to find the R Thevenin. So the first calculation is completed. I hope you might have understood this Thevenin. Now we need to calculate the Thevenin's voltage. Remember one more point. Even the Thevenin's voltage is also the open circuited voltage. That's the reason here also we have removed the load resistance RL. Now what we do is, for this mesh, okay, simple, as we are open circuiting it, here there is no flow of current. So for current I am just considering this one. So what is current? From Ohm's law, if we consider, we can write V is equal to IR from Ohm's law. So from this what we can write? I is equal to V by R. So here what is V? V is simply the voltage V. So I have written V. When I consider the resistance R1 and R2 in series. So when both are in series, we need to add them. That's the reason in place of resistance R, I have written R1 plus R2. This is the current. But what I need to find here? I need to find Thevenin's voltage VTH. From Ohm's law again, V is equal to IR, right? So current is I and we need to consider the resistance R2 here. So VTH is equal to I into R2. Now substitute I value here. Then you will get VR2 by R1 plus R2. This is the value of Thevenin's voltage. Remember one point, while calculating Thevenin's resistance as well as Thevenin's voltage, we need to open circuit it. That is, we need to remove the load resistance. And while calculating Thevenin's resistance, you need to go from back. That is, from RTH, from this side, you need to calculate the RTH. From back side. From back, you need to calculate the equivalent resistance. That is nothing but the Thevenin's resistance. Now, we have completed the calculation of Thevenin's resistance and Thevenin's voltage. Now what we do is, this complete circuit, we are replacing it with single voltage source and a series resistance. So that circuit is converted as VTH in series with RTH. Now connect the RL, load resistance, here. Now first task is completed. That is, we have calculated the Thevenin's resistance, then we have calculated the Thevenin's voltage. Now my question is, I need to find the current through this load resistance. So simply for this, if I apply Ohm's law, it's completed, right? So from Ohm's law, V is equal to IR. Then what is I? V by R. So here the voltage V is V Thevenin. So I have wrote V Thevenin by, both are in series. So I wrote R is equal to R Thevenin plus RL. In this way, we'll find the current through the load resistance RL. So this is the way of converting the given circuit into its Thevenin's equivalent and finding the current through the load resistance. So simple Thevenin's theorem states that any voltage, any linear and bilateral network with voltage sources and a number of resistances can be simply replaced with a single voltage source and a series resistance. That is known as Thevenin's theorem. And voltage and resistance both are open circuited. So RTH is known as Thevenin's resistance or open circuited resistance. VTH is known as Thevenin's voltage or open circuited voltage. Now the limitations of this theorem is, this theorem is applicable only for linear and bilateral networks. That means linear network means any network in which VI characteristics are directly proportional. That is, as V increases, I increase. So for VI characteristics, if I consider V on x-axis and I on y-axis, the graph must be a straight line. Then the circuit or the network is said to be a linear network. So bilateral means flow of current must be in two directions. Then it is said to be bilateral network. So this Thevenin's theorem is only applicable for linear, that is, for which VI characteristics is a straight line, and bilateral, in which the flow of current is in both the directions. So only for such networks this theorem is applicable. And coming to the applications of this theorem is very much useful in analyzing the power systems. So in this way, you can convert a given circuit into its equivalent Thevenins network and then calculate the current through the load resistance. I hope you might have understood the statement limitations and how to calculate the Thevenins resistance and Thevenins voltage. So if you have liked this video, please like it, subscribe for further videos. Thank you.